let's get a little practice with using our TI to graph these ellipses. Very similar to what we maybe saw in the circle ones. And I always found, just kind of emphasize this, that it's a lot easier to graph by hand. But if you need to do this, use this for something else, like solving a system of linear equations or inequalities, you may be interested in doing this technique as well. So when we are using our TI to graph, remember the whole goal is we have to be able to enter things in terms of y. So the first thing we do with our particular ellipse, it's a very nice equation to graph by hand, but we will want to solve it for y so that we could enter it into our TI. Now, if I solve this equation for y, this would involve me moving the x squared term over. So that's me subtracting it on both sides. It's a little hard to see, kind of scribbling that in there. So what we end up getting, we are getting y plus 1 square over 16 equals 1 minus x minus 2 square over 49. And now, to make things interesting, you kind of see that we're off center from the origin, so it's going to make the equation look a little more complicated. Our TI can handle most of these things without having to simplify too much, but let's take a look at isolating that y. I'm going to remove the 16. So what I'd like to do is multiply 16 to both sides of the equation. And so what that would leave me with on the left side would be y plus 1 square. And on the right-hand side, I'm not going to bother distributing the 16. There's no need to unless you want to get rid of the extra case of parentheses. But what we have here is we do have brackets. We will have to change them if we do enter them into the TI. TI doesn't recognize brackets, it recognizes parentheses. So if you want to, at this moment, you could enter the extra set of parentheses right here. Okay, so we still have to isolate that y term, so we have to undo the square. So that would involve us taking the square root of both sides. And don't forget, if you do take the square root of both sides, the right-hand side will have the plus or minus. So I'll put that in there. And what this right-hand side does, really what we're looking at, try to draw that a little straighter for you all, is you're taking the square root of 16 multiplied by 1 minus x minus 2 square over 49. And I'm not really bothering simplifying. You might be able to pull a factor of 4 out from the 16 factor, but it's really not worth it at this time. So on the left-hand side, we are left with y plus 1. We are almost there. Very last step is to subtract 1 from each side. And I'd be kind of careful here because you're not really subtracting it from the radical. It's separate. So I should get y equals -1 plus or minus square root of 16 times 1 minus x minus 2 square over 49. And so it is solved for y. If you remember the way the TI works, the plus or minus leaves us with a top half and a bottom half of an ellipse. So if we're looking at entering y1, that would leave us with -1 plus the square root of 16 times 1 minus x minus 2 square over 49. You're going to see me have to refer back to this when I write this into the TI. And y2 will be -1 minus the square root of 16. Same idea, same radicand, minus 1 minus quantity x minus 2 square over 49. So the challenge is the algebra, but not just the algebra. We do have to worry about entering parentheses into our TI. So let's take some time to do that. I may have to write this down so there's a little less switching back and forth with screens with you all. So I will do that. before I switch over. You're lucky because you get to kind of view your paper. So I don't have that luxury here. I don't have two screens. So let's switch to our TI now. And we're entering the graph, so we're going to go y equals. I have something from the circle from the past, so I will clear that out. And if you're picky and you want to turn them into the same color, feel free to. There's ways to do that, but right now we're just trying to figure out what's our picture look like. So for y1, I'm going to type in -1. Using the negative key, it's right by the enter key. We are adding this to the square root. Now, with the square root, with this version of your TI, you do have the box to help you know that when you're entering stuff in the radicand versus outside the radicand. If you have a TI-83 or a regular TI-84, you may have to use parentheses to indicate who and where your radicand should start and stop, I should say. But we're a little luckier here, so I will take that time. And if you need a little more help, contact the tutor. We'll try to help you out with that. So -1 plus, right now we have 16. That's multiplied by 1 minus x minus 2. So I've got to make that in parentheses, x minus 2 squared. And then now remember, if you don't have the nice math type in your TI, you're probably going to have to use an extra set of parentheses to talk about, the full denominator. You don't want to accidentally enter the denominator of 49 in the exponent part. So be careful there. We're going to close off that part. So it's 16 times all of that. So just in case, I may check. We'll see. I know we graphed this by hand, so we can verify that together. Let's move to y2. It's -1 minus. And now we'll just take the square root and we'll copy everything we did. The radicand is the same. It's the outside that's a little different. So 1 minus x minus 2 exponent of 2 divide by 49 and close off that factor. Oh, there's an extra parenthesis. Be careful. Okay, so we're going to cross our fingers. We're going to graph it and see if we get an ellipse. And we have. Very nice. So let's see if we can copy that over. Last time I didn't have luck, but we'll try this. Go back to our particular problem. It says it wants us to verify the graph is the same as the graph by hand in our previous example. So let's go back and look at where that previous example is. Looks like we have the one where we have the shift. That is this one. Okay, see if this will let me plot it right here. There we go. A little better of luck. Let me see if I can move it a little bit, or I'll make it a little bigger and move it next to it. And what do you think? Not bad, huh? So you'll kind of see, yes, the top half was y1, the bottom half was y2. Technically, it should be all the same color. And also a little bit of the limitations of the TI. It has to do with the fact that it doesn't always connect the top and the bottom, but you can clearly see there is a nice resemblance to what we did by hand. So just reiterating, I personally think it's faster to graph by hand, but the reason why we go over this in this section is when you hit chapter 7, you may be interested in typing these into the TI. You also could look, if you read your appendix, there might be an app that helps on your TI, a little bit more, a nicer version of how to graph these conics. Feel free to explore. I'll leave that up to you, leave the fun to you. I'll see you in the next example.